Good morning. Sorry for the delay. I never could get it to pull up on my screen, but finally. All right, looks like we got everybody 1, 2, 3, 4, 5, 6, 7, except for April. Hopefully she'll log in soon. So I just emailed the test, okay? So look for that after class. It should be there. It is due, like I said, the Wednesday that we return to co-op after a break. So any questions about that? All righty. And then, excitingly, we started a new chapter yesterday. So we are going to go ahead and take a look and see if we have any questions on the homework. Let me go ahead and pull this up real quick. Nope, that's not what I need. Okay, let's see. All right, here we go. So just a quick review of what we looked at yesterday, talking about our triangles. We talked about how there's two ways to classify triangles, and that's according to their sides and according to their angles. And when you are trying to be as specific as possible, you want to name them by both, okay? So, so that's what our picture here in the green box is it's showing us how to name them according to both sides and angles, okay? Get my screen ready so I can see when April pops in. All righty, so we talked about that. We looked at how to identify the different parts of a triangle. We talked about the places where the points connect with two lines is called a vertex. And if it's more than one, we refer to it as vertices if it's the plural. We talked about if there's a right triangle, that the two sides coming off that are adjacent to the right angle are called legs. The side opposite the right angle is the hypotenuse. All other triangles, we use two legs and a base. We talked about interior angles of a triangle equals 180 degrees, and as well as the exterior angles of a triangle. And to be able to find the exterior angles, you just extend out each leg of the triangle to make a straight line. And we know that this side of the triangle would be 180 degrees, but then when it comes off here, the exterior part of the angle would be out here, okay? We looked at, on page, let's see, page 196, the triangle sum theorem, where we learned that angle plus angle plus angle, 180 degrees, exterior angle theorem again, the outside. So one of the things about the exterior angle theorem was that the outside angle is equal to the sum of the two interior angles, okay? And one of the things, I don't know if this will help or not. Again, one of those kind of silly things that I do. When I look at this, I kind of, y'all know me and all my silly stuff. Like if I was looking at my triangle and this is the door to go outside, okay? So my door angle is equal to the two back bedrooms, okay? So it's like if you came in the door, then I can look at these two angles and add them together and it equals this. I don't know, thinking exterior, it's a door, I don't know if that helps or not. Again, it's one of my just kind of silly things that if you think about your exterior angle is kind of like going into the house, and then those back rooms are like your back angles are like the back rooms, but you add the angles together to equal that exterior angle. Finding an angle measurement. So in this situation, we use that formula where the exterior angle is equal to the sum of the interiors. And so then even when we have an algebraic equation, we can set it up to be able to solve for our variable. The corollary to the triangle sum theorem, we talked about the acute angles of a right triangle are complementary, because we talked about how the right angle, we can't have more than 90 degrees. Our interior angles cannot be more than 90 degrees added together, because it cannot go over 180 degrees. So our other angles are going to be complementary. And that was about it on this section. So hopefully, if you haven't had a chance to go over your homework yet and do that, we'll do another homework check on the Wednesday we get back. We'll go through these. If you have had a chance to work on homework, do you have any questions before we move forward? All righty, then we will go ahead and move on to 4.2, congruence in triangles. All right, so it says two geometric figures are congruent if they have exactly the same size and the same shape. So I'm going to highlight that. So congruent, same size, same shape. So it says each of the red figures is congruent to the other red figures. None of the blue figures is congruent to another blue figure. So you can see that on the red side with congruent, they're all the same shape, they're all the same size, they're just positioned differently, okay? Maybe it's flipped, maybe it's turned, rotated, whatever you want to call it. So it's just moved around in some way. Whereas if you look at the blue ones, none of them are the same shape. Except for your two triangles. The two triangles are the same shape, but they are not the same size, therefore they are not congruent. So it says when two figures are congruent, there is a correspondence between their angles and sides, okay? So between the angles and sides, such that the corresponding angles are congruent and corresponding sides are congruent. Okay, so that means that if I look at the location of each of the angles within the triangle, so just like our picture here, again, this is where our little hash marks and our little angle markers come in handy, because I can see that right here, oh, go back, right here, I have a single angle arc. Same thing here, I've got a single angle location here, because those are corresponding. Remember, corresponding means they're in the same location. So corresponding angles of a congruent triangle are equal. So we can see that B is congruent to Q, A is congruent to P, and C is congruent, well, I'm writing pi, good grief, to R. Based on those marks, I can see that B and Q are congruent, A and P are congruent, and C and R are congruent. That's as far as our angles go, okay, when I'm looking at my angles. Then I can also see where side AB is congruent to side PQ because I've got that single mark there. I can see that side BC is congruent to side QR. I can also see that side AC is congruent to side PR. Okay, so that's basically what they just told us right over here. I just wanted you to see it from the pictures. So same thing here. Again, each time you see a figure, I want you to get in the habit of seeing what you can figure out about it before you look at what the text tells you about it, because you figuring it out is going to help you more than just somebody going, this is what it is. Okay, so it says there is more than one way to write a congruent statement, but it is important to list the corresponding angles in the same order. Okay, so one of the things what that's talking about is I would not want to name, and I'm going to erase this that I wrote up here so we can look at it. In this situation, I would not want to say side AB is congruent to side QP. I don't want to say that because that's not putting them in the same order. AB, I'm going in this direction. QP, I'm going in that direction. I want to make sure that when I'm naming corresponding sides, that when I name one going in this direction, I name the other one also going in the same direction. So I want to make sure that if I started with A, that I start with the corresponding vertex. Okay, so the main thing is, now I could name it, I could say BA is congruent to QP. Whoop. I could say that because then I'm going in the same direction. So that's what they're meaning, that there's more than one way to name it. I could do AB is congruent to PQ, or I could do BA is congruent to QP. But I want to make sure that whichever one I start with the corresponding point. Does that make sense? Any questions about that? All righty. So naming congruent parts. The congruent triangles represent the triangles in the photo above. Write a congruent statement. Identify all pairs of congruent corresponding parts. So basically, if you were just given two pictures and it said name all congruent parts, then you're doing exactly what we did up there with those pictures. You're looking at it and saying, okay, I can see that E is congruent to S. Now again, it doesn't matter which one you start with. You could start with F and R, D, I'm sorry, not F and R because F goes with T. But I can start with E and S. Then I can see that if I go to F next, F corresponds with T. Again, I'm looking at those angle marks. They have flipped it, so you've got to look and see which ones correspond. And D is with R. Okay? Now I can look at my sides and I can see that side, I had trouble with this. I guess it was, I don't remember if it was this class or the other where my screen keeps popping out, so I don't know why. It's a bit frustrating, but we will try to get it linked back up. I don't know if it's an internet thing. I may need to restart my router between classes and see if that'll help. Okay. All right. So like I was saying, ED is going to correspond with RS. And then I can see that EF corresponds. Now this is where it gets tricky, because notice I started EF. I started at the side at E, so I want to start with the corresponding S to say ST. Okay, so even though I went up this way and down this way, it's because of the rotation of the shape. So E corresponds with point F, angle E and angle S, so I want to name it as EF and ST. And then the last one we would look at would be that DF corresponds with RT. Again, I started down here at D that has my double swipe or my double arc, so I would start at R to name that one RT. Okay.
So why wouldn't it be DE is congruent to ST?
Okay, so do you see our hash marks?
Oh, I see that. Yes.
So there's only one here and there's two here.
Yes, ma'am.
Okay, so you want to pay close attention to those to make sure what corresponds with what.
All right.
Now, if you're not given hash marks, a lot of times it may be that you're given measures, you're given numbers for your sides or angles or things like that, and that's what we're going to look at in just a minute. Okay? Okay, but I'm glad you asked that question. It's because then, you know, you can see when your angle is flipped around like that, you just got to pay attention to the corresponding sides and angles. You can't just assume that it was flipped side to side. It was actually rotated around. So this one is an actual rotation where it was turned. All right, so let's look at example 2. It says using properties of congruent figures. So you can see that we've got two congruent figures. Again, it's rotated around, so I've got to look and see which angles correspond with each other. And then it says, so it says in the diagram, NPLM, so that's the name of that shape, corresponds with EFGH. Okay, so one of the things to mention here is notice that when I'm not sure what corresponds with what, I can look at the way it's named. And notice that they said N came first, so that means N corresponds with E. Okay, and then so I can look at my picture and come over here and say, okay, I know that N and E correspond because they were both written first in the naming of the shape. So then I can look at the next letter and I see that I have P corresponds with F. So I can come over here and I know that P and F are corresponding angles. My next one I look at, I have L that corresponds with G. So L and G. And then finally, I've got M that corresponds with H. So M and H. Okay, so the way that my figures are named, like I said, we're not always going to have these hash marks. We're not always going to have the angle arcs to tell us which ones are congruent. So now I need to pay attention to how they are named. So when I see the name of it, I can tell which angle corresponds with the other angle. So in this one, it says to A, find the value of X. So when I look at my figure, that involves X. And I can see here that X is the length of GH, okay? So GH is equal to 2X minus 3 times M, okay? So I said GH equals 2X minus 3 times M. So now I've got to look and see, okay, what is my corresponding side that goes along with that? And so that is going to be, and so we said this was GH right here. So when I look at my corresponding sides, that would be LM. So now I can set it up to where I know LM equals 8. Okay, has everybody followed me so far? So now what I want you to do while I'm bringing my screen up is go ahead and set up your equation where we have the measure of GH is equal to LM. Okay, finally. So since LM equals 8, GH equals 2x minus 3 times M, I can set up an equation where I have 2x minus 3 times M equals, and I guess the M is talking about like meters. So that's our standard of measure. So in our problem, so don't let that throw you off. Okay. So in our problem, I'm going to take that M off because it's talking about meters. So 2x minus 3 equals 8. So add 3, 2x equals 11, divide by 2, x equals 11 over 2. I did something wrong there. Okay, 11 over 2 equals 5.5. So they just went ahead and put it as a decimal here. Okay. But notice that all I had to do in that problem, again, you're not going to have this part where it tells you what to do. You've got to figure out how to do that. So that's what I just showed you, is to be able to say, okay, I know that GH is 2x minus 3. I know that LM is 8. I know because of our corresponding figures, or because they correspond and are congruent, that means that those sides are equal to each other. So I can set each of those equal to each other and solve for x, okay? So one of the things that I think I've been in the habit of with Algebra 1 is that whenever we had a fraction, we could leave it as a fraction in lowest terms, and in geometry, we're going to go ahead and convert those, unless it's like a slope or something, we can go ahead and convert those to decimals. So that's what we found here. We set them equal to each other and found that x is equal to 5.5. Same thing with y. I'll go ahead and erase this, my little lines here. Erase this up here, and we will solve for y. So now I can see that my angle here is 7y plus 9. Now notice the difference. You can tell that this is talking about an angle because it has that little angle, that little degree mark, okay? So on the outside, it had the M for meters to show you that it's talking about a length. That way you don't go, well, how do I know if it's talking about an angle or a length? How do I know which one it is which? Because they've got their measurement letter to show you length, and then we've got the degree to show. So I can see that I know that angle E and angle N correspond. I see that angle E is 7y plus 9 and angle N is 72. Since they are congruent, that means they're equal to each other. So I can set up an equation where 72 is equal to 7y plus 9. Divide both sides by 7. I'm sorry, well, first of all, subtract 9 from each side, then divide by 7, and you find that y equals 9. Any questions on how we were able to figure out how to set up these equations? To be able to set them up, you must first have an understanding of the relationship of the angles and the sides of each congruent figure, okay? So I don't know if it helps you if you want to rewrite it or draw it on your paper and use colored pencils and color just like I'm doing on my pad so you can kind of see the connections there. Or if you just want to, you know, the first thing that you do before you even work out the problem is before you get the problems, go ahead and show what are my corresponding sides and corresponding angles, whatever you have to do to be able to see that. All right, our next theorem, it says the third angles theorem below follows the triangle sum theorem. Okay, so here the third angles theorem says if two angles of one triangle are congruent to the two angles of the other triangle, then the third angles are going to be congruent as well. So in this picture, we can see that they've told us that B and E are congruent and that A and D are congruent. So if I already have two congruent angles, then I know that C and F will also be congruent. Okay, so that is called our third angles theorem. Third angles theorem says the third angle will be congruent if the first two angles are congruent. Okay. So now in example 3, we're going to use the third angle theorem. And so it says we need to find the value of x. So the first thing I want to do is I want to look at my shapes, and I want to see what I know. And I know that L and S correspond. I know that, I'll put a box around N and R correspond. So that means that M, I'm going to go ahead and put it as a 3 line since the first 2 are already marked. M and T correspond. Okay, so I understand my relationships of corresponding angles here. So now what I've got to do is be able to figure out solve for x. So I want you to look at that for a minute. I don't have an angle measure for M to be able to set 2x plus 30 equal to it. So does anybody have any ideas on how I can figure out the measure of angle M?
N and L is 65 and 55.
Uh-huh.
So wouldn't you just like go in between that?
Go in between that, what do you mean?
Like go 60, because I don't know, like that's what I would do.
Okay. No. Think about what information do you know? What do you know about triangles?
They equal 180.
Yes, they equal 180. So how can I figure out what the measure of M is?
Subtract 180 minus 55 minus 65.
Very good. So because I know that my interior angles are going to equal 180, and I know that one angle is 55 degrees and the other one is 65 degrees, then I can go ahead and add those together. And I know that 55 plus 65, I know that if I were to add those together and subtract from 180, so go ahead and do that right now. What is 180 minus 55 minus 65?
60 degrees.
Okay, it is 60 degrees. So it worked out in that situation, didn't it, Easton? So, but that's not always going to work. So I don't want you to get in the habit of just saying, oh, the next one is going to be in the middle, because I do not know that for sure. What I do know for sure, based on my theorems and postulates, is that the inner angles equal 180. So I know that for sure I can start with my 180 degrees and subtract 65 and 55, and I end up with 60 degrees. So knowing that, I can now say, I can go ahead and label angle M as 65 degrees. So I'm going to go ahead and mark that that is 65 degrees. So the first thing I had to do was solve for my unknown measurement. Now I know that angle M is congruent to angle T. Therefore, 65 degrees equals 2x plus 30.
Where did you get 65?
I'm sorry, it's supposed to be 60. My bad. 60 degrees. So let me fix that here. Okay, so 60 degrees is equal to 2x plus 30. Sometimes my hand writes faster than my brain is working, and so sometimes it just doesn't write down the right way that I'm meaning it to. Okay, so to be able to solve for x, I subtract 30, subtract 30. So I have 30 is equal to 2x. Divide by 2, x is equal to 15. Now, my question only said to solve for the value of x. If it said to find the measure, then remember I could just plug x in to 2x plus 30. Okay, and so I could say 2 times 15 plus 30 equals 30 plus 30, which equals 60 degrees. Okay, so I can always plug in what I found for x to check my answer, or if it said to give the measurement. Okay, so because I knew that two of my angles were congruent, I know that the third angles will also be congruent. Because I know that an angle's interior measurement is 180 degrees, we were able to solve for the third measure, use that third measure to set it equal to my equation for the third measure of the second triangle, and then solve for x. Any questions on that? All righty. Now example 4 says determining whether triangles are congruent. Decide whether the triangles are congruent. So we're going to take a look at this. So again, I can see that
I need your consent on a few items to continue.
technology is not being my friend today. Okay, so I can see that I have RP is congruent to MN. Okay, so I see that those are congruent. And so if, notice that when I started saying that, I said R first, which was next to my side that had 3 hash marks. Therefore, when I said, so I said RP is congruent to MN, because I started with R here, which R was the angle between my 1 and 3 hash marks. My angle between 1 and 3 hash marks over here is M. So remember, I need to name them in order. So that means that if R and M correspond, then angle P and angle N correspond. Okay? So just paying close attention to naming them in the proper order. So here it says, from the diagram, you're given that all 3 pairs of corresponding sides are congruent. So RP is congruent to MN, PQ is congruent to NQ, and QR is congruent to QM. Because angle P and angle N have the same measure, angle P is congruent to angle N. By the vertical angles theorem, you know that angle PQR is congruent to angle NQM. By the third angles theorem, angle R is congruent to angle M. So all 3 pairs of corresponding sides and all 3 pairs of corresponding angles are congruent. So by the definition of congruent triangles, triangle PQR is congruent to triangle NQM. Okay, so that's given the reasonings. I do not know why this is giving me such trouble. Okay, we'll go on to example 5, proving 2 triangles are congruent. So again, we'll just kind of look through this, understand the relationships, because remember, our whole thing, we want to be able to know why we're saying that 2 things are congruent. Okay, so we have a diagram, and we can see my corresponding sides, and we can see our little arrows right there. That means that those 2 sides are parallel. So we can see our measurements there. So it says given, side AB is parallel to side DC, and so AB is congruent to DC. E is the midpoint of BC and AD. Okay, so I can see that that is the midpoint there. So I need to prove that triangle AEB, so I'm talking about AEB, this triangle, is congruent to triangle DEC. So those are the 2 triangles I'm trying to prove congruent. So I know that my given tells me that side AB is parallel to DC. Therefore, those 2 sides are congruent. So it says plan for the proof. Use the fact that angle AEB and angle DEC are vertical angles. So look at that here. I can see that this angle here, let me use a different color, that this angle here and this angle here are vertical angles. And remember, vertical angles are congruent. So it says, use the fact that AEB and DEC are vertical angles to show that those angles are congruent. Use the fact that BC intersects parallel segments AB and DC to identify other pairs of angles that are congruent. Okay, so we can see that they started out with the given. Okay, this information was what they gave us up here. Now, one of the things I want you to notice is they only started with the first point of the given. They didn't tell us yet that E was the midpoint of BC and AD. They are holding off on that. So basically they started with my parallels, and because they're parallel, they're congruent. So then they said angle EAB is corresponding with, or is congruent to angle EDC, and angle ABE is congruent to angle DCE, and this is our alternate interior angles theorem. Okay. Then they said that angle AEB is congruent to angle DEC, and that was our vertical angles theorem. So once we had gotten that far, they said, okay, the E is the midpoint of AD, and E is the midpoint of BC, and again, that was from the given. So now side AE is congruent to DE, BE is congruent to CE, and that's the definition of a midpoint. Therefore, triangle AEB is congruent to triangle DEC, and that's our definition of congruent triangles. Okay? Again, understanding the relationships to me is more important right now than getting bogged down on these proofs. All right? I want you to be able to see that AB is parallel to DC. I want you to be able to see that because those are parallel, they are also congruent. I want you to be able to look and see that AE or that EAB, when I start here, EAB, okay, I'm talking about this angle right here, is congruent to EDC. EAB is congruent to EDC. Okay, so remember that when we talked about our lines, I can see that this angle here, that's not what I wanted to do. I'm on the wrong side. That this angle here and this angle here are alternate interiors. Okay, so remember that if I were to extend my line out here, if this went that way and this went that way, remember they told us that these two are parallels. So we know that we've got this as our transversal. And so when we look at that, I can see that these are alternate interior angles. Okay, so again, one of the things that we're having to do here is understanding that even though we've got it drawn as a finite shape on my paper, I can still extend these sides to help me see these different angles here. Okay, so again, we've got all these different understandings of angle relationships with the alternate exterior, alternate interior, corresponding angles, all of these different things. I'm taking everything that I have learned and putting it all together in each chapter. So whereas a lot of times, like in algebra and pre-algebra and things like that, you would cover a skill in algebra and then you'd move on to the next skill. Sometimes it would bring in something, maybe like, you know, dealing with radicals and things like that. You might have some of that in further units. But with geometry, I'm taking everything that I have learned previously. In each chapter, I'm incorporating things that I have previously learned. Okay, so I can't learn it in isolation and go, okay, I'm done with that. Let's move on to this. Okay, so just like we can't say, hey, I've learned about alternate interior, alternate exterior, corresponding, all that stuff. I learned that in chapter 3. I don't need that for chapter 4. Yeah, you do. Okay. So that's why I'm trying to help you understand the relationships and be able to see them for yourself without me having to tell you about them. All right, so the next one says, in this lesson, you have learned to prove that two triangles are congruent by the definition of congruence. That is, by showing all pairs of corresponding angles and corresponding sides are congruent. So the definition of congruence, all pairs of corresponding angles and corresponding sides are congruent. In the upcoming lessons, you will learn more efficient ways of proving that triangles are congruent. The properties below will be useful in such proofs. So they're telling us right here that these proofs that we're using are going to be used in upcoming sections as well, okay? So the first one, you'll recognize some of these words that we're using here. And so we have the reflexive property of congruent triangles. We've got the symmetric property of congruent triangles, and we have the transitive property of congruent triangles. So remember, it just reflexive means that something is equal to itself. So every triangle is congruent to itself, okay? Congruent to itself. Symmetric, remember symmetric is like our line of symmetry where we have the mirror image on either side. So knowing I've got that mirror image, it says if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. I'm just saying the same thing, but I'm saying it in reverse order, or it's that mirror image. And then transitive, if triangle ABC is congruent to triangle DEF, and DEF is congruent to JKL, then I know that ABC is congruent to JKL. Okay, so we've learned these words. We've learned, so basically we can use these for angles. Now we've learned we can use them for triangles. We've used them for segments, the reflexive, symmetric, and transitive properties. All right, so in this section, we've got our guided practice, and it says to copy the congruent triangles shown at the right and then label the vertices of your triangle so that triangle JKL is congruent to triangle RST. Okay, so let's check our time. I think we've got a few minutes. It's 9:18. We've got, well, I guess we only have 2 minutes till break. So maybe that we go ahead and get a piece of paper and draw these two triangles. And then once you have drawn your triangles, you don't have to label anything, just jot them down real quick. And then we'll take a break. And when we come back, we'll start labeling them. Okay, so just go ahead, and once you have drawn your triangles, you can take a break, and we'll come back in about 5 or 6 minutes, and then we'll get started again. Okay. All righty, let's get back to it. So hopefully you have drawn your triangles. And now we're going to start identifying all pairs of congruent corresponding angles and corresponding sides. Okay, so the first thing it said is we need to name our points first. Okay, but remember, I want to make sure that I name, if it's triangle JKL, then I want to make sure J and R are corresponding. So let's go ahead and I'm going to go ahead and just name J my top point and R my top point. Then I know my next letters will be K and S. So I want to make sure that I make those corresponding. So I will make these, let's see, this will be K and this will be S. And then we will have L and T. So I'll make this one L and this one T. Okay, so the first thing we wanted to do is look at the order that our triangles were named in. We wanted to make sure that because they're congruent to each other, that I made sure that the corresponding points were named properly. Okay, so given this, now I want to, since we went ahead and named our corresponding points, now we can go ahead and do our corresponding angles. So we know that J and R are corresponding, so I can put my single arc there. I know that K and S correspond, so I'm going to put 2 arcs there. So L will have 3, T will have 3. All right, now we've got to do our sides. Now we know that JK is going to correspond with RS. We know that KL will correspond with ST, and that JL will correspond with RT. Everybody comfortable with labeling those? Any questions on that? Okay. So then we could look at it and we could label, if we, so we labeled it. Now we want to go ahead and write it out. Okay. So the way I would write this in statements would be angle J corresponds with angle R. Angle K corresponds with angle S. Angle L corresponds with angle T. Then to name my sides, I'm going to go above so I can write there. So I would have JK corresponds with RS. KL corresponds with ST. And JL corresponds with RT. Okay, so by labeling those triangles, it helps us to see which ones are going to correspond. And then again, we want to make sure that we write the letters in the proper order. All right, let's look at the error analysis. It says use the information and diagram below. On an exam, a student says that triangle ABC corresponds with triangle ADE because the corresponding angles of the triangles are congruent. Okay, so let's look at our diagram. I can see here that I have got angle ABC. Okay, we've got that triangle there. Then the other triangle they are looking at is going to be the bigger triangle, which would be this whole entire triangle. So basically they've overlaid the 2 triangles, but if we were to separate them and pull them apart, we'd have 2 separate triangles. Okay, so they did find that angle B is congruent to angle D. Angle C is congruent to angle E. Therefore, we know that angle A, we can also see that they're located in the same place, that they're congruent as well. So all of my angles are congruent. Okay? So we know that, but look at number 3. Is triangle ABC congruent to triangle ADE? Think about congruent triangles. What is my rule
No.
for congruent triangles? No, why?
Because, what's it called?
Remember we said with congruent triangles, the angles have to be congruent, but what else has to be congruent? My side lengths. Okay, so I can see here that when I'm dealing with AB, AB is not the same length as AD. Okay, remember congruent triangles are same size, same shape. Okay, so these are the same shape, but they're not the same size. So that's the biggest thing there, is they are not the same size. We would call these similar triangles. Similar triangles are triangles that are the same shape, but they're not the same size. So these would be similar, not congruent. Okay, so congruent triangles, same shape, same size. These are the same shape, they are not the same size. So that is what is wrong here. And the reason is because my sides are not congruent. All righty, let's look at numbers 4 through 9. It says use the diagram at the right where our triangle LMN is congruent to PQR. So what I want to do first is I want to say, okay, I know that angle, that L corresponds with P. So I'm going to circle those. I know that M corresponds with Q. So I'm going to put a box around those. And then I'll just leave N and R. Okay, so I can tell what are my corresponding angles by whether it has a circle or a box. And then that way, as you're labeling things, as you're working, you don't have to necessarily have different colors. All right, so if we know that L and P are congruent, then what is the measure of angle P? It's
105.
105 degrees, good. If angle Q is 45 degrees, what is the measure of angle M?
30.
Nope, look at M. Q and M are the same. So Q is 45 degrees, so M is also 45 degrees.
What's it called?
So now we've got to look at N and R. So N and R are going to be how many degrees? That's where they're 30. Okay, because 100 plus, 105 plus 45 equals 150. Okay, so I know that these two angles here equal 150. I know a total triangle inside is 180 minus 150 is 30. So I was able to find that other side.
I need your
Okay.
consent on a few.
Any questions on how we did that? So now let's look, and it says, what is the measure of angle P? We found that angle P is 105 degrees. Angle M was 45 degrees. Angle R is 30 degrees. N is also 30 degrees. Which side is congruent to QR? So what I'm going to do is I've got QR. Let me make it a different color so it'll stand out.
MN.
Okay, so QR, and notice that I started at point Q at 45 degrees. Therefore, it's going to be MN. So MN.
So when you're working these out, you just have to like look for the things that are alike.
Yes, you've got to look for the corresponding locations. So like with that one, they started with Q, okay? And so when I'm doing a congruent thing, I've got to start with what point or what angle is congruent with Q. That is M. So that's where I have to start naming it. So that way I know that Q and M correspond and R and N correspond. They've got to be in the same order. So now which side is congruent to LN?
PR.
Okay. So LN, I'm starting at L and going to N. So I've got to go to my corresponding point with L, which is going to be P, and do PR. Okay, so going in the same order, PR. Any questions on that? Are you feeling okay about it? All right, so starting with our practice and applications, let's go ahead and take a look at what our homework will be. We will be dealing with page 206 to page 208. Okay. And we will do numbers 11 through 35 odds. Pages 206 to 208, 11 through 35 odds. So let's kind of scoot through those a little bit and take a look. You can see here, well, the first section, we're looking at our triangles. We are looking at what are our corresponding angles. We've got to figure out what our missing angles and our missing sides are. Let's see, then congruent figures. You can see that we've got everything already labeled for us. So, and so it says to identify which figures can be proved congruent. Explain your reasoning. For those that can be proved congruent, write a congruent statement. So what it's saying is that when you're writing the congruent statement, you're basically saying that these angles are congruent because, so like, let's look at number 16 together for a minute. Okay. Notice that here I have got this joining line BD. Okay. So think about our three properties that we talked about: reflexive, symmetric, transitive. Okay. And if we look at these and we've got this joining line, we can look at it as kind of how that line, it's that mirror image. I mean, it's basically the, I don't want to say that. In my book, it's saying BD is equal to BD, but to me, naming it, you're going to have to say that BD is equal to DB. So to me, that would be symmetric versus reflexive. So basically what it's saying is look at the statement and say, you know, are they corresponding? I mean, are they congruent? And if so, why? Are there any of the things that we've looked at so far that can help you to determine that? And then also looking at the angle placements, looking at your side measures, are they properly labeled? Okay, so you're looking to see if you can prove that they are congruent or disprove because, and tell me why. All right, let's look at 23 is just critical thinking. Use the triangles shown at the right. How many pairs of angles are congruent, and are the triangles congruent? And explain your reasoning. If you say yes, they're congruent, tell me why. If they're not congruent, tell me why. You can see that on 25, I'm going to have to be able to look at my triangles. Now notice, if it says given that they are congruent, you can look at that, and even if they don't necessarily look like they're exactly the same, because in this one, I'm sure that if I cut them out and put them right on top of each other, maybe they're the same. But to me, they look a little off. but I have to trust my directions. My directions said that they are congruent. So I'm going to start by pairing up X and R, Y and S, Z and T. I'm going to use that to determine, to be able to solve for A and B using my congruent angles, okay? Moving on down to 27, it says use the given information to find the indicated value. So again, on 27, you're going to be doing the same thing, same with 29, okay? Moving down, talking about crop circles, it says use the diagram based on the photo. The small triangles, triangle ADB, CDA, and CBD are congruent, okay? So it says in 31, the sum of the measures is 360, so find the measure of BDC. And then 33, it says explain why triangle ABC is equiangular. Moving on to 35, we've got a proof here, okay? So I want you to look at that and think about, do the best you can trying to identify your reasons on how they got from step 1 to step 2, from 2 to 3, from 3 to 4, okay? So just practice doing that. And they've given you the last reason, and they left the statement blank, so hopefully that should be pretty easy to fill in number 7. As well as number 1. We know at least hopefully you'll get 1 and 7 on your own. Okay, so just try to think through, try to look at those relationships, think about the statements and the theorems and the definitions and all that stuff that we've learned previously to figure that out. All right, so we said 11 through 35 odds. You'll go through the process, label your paper, put what lesson it is. This is 4.2. Write whatever notes you need to write at the top. Again, if we kind of look at this, we would, I would hope that you would write congruent triangles, have the same size, same shape. Congruent triangles have corresponding sides and corresponding angles. And then you could do reflexive property, symmetric property, and transitive property. So those are going to be the main things that we've learned from this chapter that you could put at the top of your notes and then go through and work them. After you've completed your work, check it, make corrections. Okay? All right, so now we are going to move on to 4.3. And 4.3 is proving triangles are congruent using SSS and SAS. Okay, so what that means is SSS means side, side, side. That if I'm proving them, I'm showing that this side is congruent to this side is congruent to this side, this congruent to this side. So SSS means side, side, side. SAS is side, angle, side. Okay, SSS is side, side, side. SAS is side, angle, side. We're going to look more about that, or look at that a little closer. And it says, how much do you need to know about two triangles to prove that they are congruent? And so it says in 4.2, we learned that all 6 pairs of corresponding parts, sides and angles, are congruent, then the triangles are congruent. So remember in the last lesson, we had 6 parts that were congruent. We showed that each angle, we had 3 angles congruent to 3 angles, and we had 3 sides congruent to 3 sides. So that's a total of 6 things that we showed were congruent. Okay, so in this one, we're actually going to be looking at how can I prove congruence not using all 6. Okay, so here it said sides are congruent. We can look at AB is congruent to DE, BC is congruent to EF, AC is congruent to DF. We also talked about the angles. Angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. Therefore, triangle ABC was congruent to triangle DEF. And it says in this lesson and the next one, so this lesson and next lesson are going to be dealing with looking at how I can show that they are congruent, not using all 6. So it says you will learn that you do not need all 6 of the pieces of information to prove that triangle is congruent. For example, if all 3 pairs of corresponding sides are congruent, so let me put this up real quick. So if all pairs of corresponding sides are congruent, then the SSS congruent postulate guarantees that the triangles are congruent. And so that is what we have as postulate 19, side, 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 or SSS congruent postulate. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. Okay, so that's all it means. 3 sides are congruent of one, 3 sides are congruent of the other, then I know that the whole triangle is congruent. Because having the same side measurements are going to create the same angle measurements. So if my sides are congruent, then I know that the angles are going to be congruent too. So example 1 says, using the SSS congruence postulate, prove that triangle PQW corresponds with triangle TSW. And so it says the marks on the diagram show that PQ is congruent to TS, PW is congruent to TW, and QW is congruent to SW. So that's all you have to put there, is that, you know, that shows that I've shown that 3 sides are congruent, therefore my triangles are congruent. The next one, it says the SSS congruence postulate is a shortcut for proving 2 triangles are congruent without using all 6 pairs of corresponding parts. The postulate below is a shortcut that uses 2 sides and the angle that is included between the 2 sides. So it says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of the second triangle, then the 2 triangles are congruent. So notice here, I'm talking about PQS, WXY. Okay, so when I'm talking about my 2 sides, actually, let me do this. These 2 sides, these 2 sides, and the included angle. So the included angle is the angle that is in between the 2 sides. Okay, so that's what it means by the included angle. I've got PQ is congruent to WX. Angle Q is congruent to angle X, and angle QS, line or side QS is congruent to side XY. Therefore, my triangles are congruent. Okay, so side, angle, side, just like it is written, where I have a side, the angle is included in between my words. So I know that my angle will be included in between my 2 sides of the triangle. That's why it's named like this, because I'm looking and I've got side, angle, side. Okay, so that's the main thing to remember there, is that when I'm naming them, my angle is in the middle. So example 2 says, using the side, angle, side congruence postulate, prove that triangle AEB is congruent to triangle DEC. Okay, so again, we have to think about the way that that was named. AEB means I'm going AEB and then DEC. Okay, so I'm naming them, and I can see that BE is congruent to CE, AE is congruent to DE. And then my middle angles are the ones that are congruent to each other. Also, we can look at that, and so we have the given, and then we can look at angle 1 and angle 2, and we know that those are congruent by the vertical angles theorem. Remember, my vertical angles have the same measures. If I were to picture these instead of triangles, I could picture these as lines. Let me get, where's my black? So remember that I could extend these out, and I could say that this is a line here, This is a line here, and that one's not as good. Okay, so if I were to picture those as two intersecting lines, I could see that 1 and 2 are vertical angles. We have learned that vertical angles are congruent. Therefore, they have the same measure. Therefore, if we know that AE and DE are congruent and BE and CE are congruent, we can prove that 1 and 2 are congruent by the vertical angles theorem. Therefore, triangle AEB is congruent to triangle DEC by the side angle side congruence postulate. Okay. Now this one says modeling a real life situation, choosing which congruence postulate to use. It says decide whether enough information is given in the diagram to prove that triangle PQR is congruent to PSR. If there is enough information, state the congruence postulate you would use. So let's look at this real quick. Okay, in looking at this, if I know that QR is congruent to SR, and I know that QP is congruent to SP. Okay, looking at those. What else do I know from this information?
PSR is congruent to PRQ.
Okay, I know that those angles, because my sides would be congruent, my angle. Also, think about what did we learn? Let me look back and see which number it was. Flip back for just a minute to maybe jumping ahead because I was going to say also if we know that two sides are, I know we talked about the third angle theorem. But it didn't specifically tell us that, but we're still using side, side, side here. Oh, duh. We don't have to have, okay, so if we look at PR is the side that they are sharing, right? So if they're sharing this side, if we know that PR is equal to PR, right? So we know that that is the same measure. So PR, so we know that we've got one side that is equal, two sides equal, and since they're sharing this third side, it is equal as well. So we were able to use side, side, side to show that they are congruent. Okay? SR is congruent to QR. SP is congruent to QP. And since PR is the exact same, we know that it's equal to each other because the reflexive property tells me that PR is equal to PR, okay? So that's what it says here. By the reflexive property of congruence, we know that RP is equal to RP, or PR is equal to PR. And so that way we've got three congruent sides. So if that's three congruent sides, we're using side, side, side. Example 4. Proving triangles congruent using architecture. So it says you are designing a window shown in the photo. You want to make triangle DRA congruent to triangle DRG. You design the window so that side DR is perpendicular to AG and RA is congruent to RG. can you conclude that that triangle DRA is congruent to triangle DRG? Okay, so what we're going to look at here, it has told us that DR is perpendicular to AG. Okay, so when I'm looking at that, I know that if it's perpendicular, what kind of angles are formed? I would have
90 degree.
Huh?
90 degree.
Exactly. So I've got that 90-degree angle. So I know if that one's 90 degrees, then this one's 90 degrees as well. Okay. So now I know that they share that 90-degree angle. I know that RA and RG are congruent. So I know that based on my little hash marks here, and because my proof told me that these are congruent to each other. Okay. Also, what do I notice here? That DR is a common side. So using the reflexive property, I know that DR is congruent to DR, right? So again, I'm breaking down my figure before I even start to think through my proof. The first thing we said was, hey, if they are perpendicular, I know I've got right angles. So then I'm going to have an angle in the middle. So now we have found we've got a side in common, an angle and a side. So now I've got side, angle, side in common. So when we do this proof here, we start with the given. Okay. We show that DRA and DRG are right angles. Okay, and that was basically if two lines are perpendicular, they form four right angles. We were able to show that angle DRA is congruent to DRG using the right angle congruence theorem. Okay, remember that a right angle is equal to a right angle. So that's what that one is saying. Now back to RA is congruent to RG. That was my second part of my given. And so because of that, if those are congruent, I also know that DR is the same as DR because of the reflexive property. Therefore, my triangles are congruent using side, angle, side. Okay. All righty.
My computer had to restart, so
Okay.
phone.
That's fine. All righty, and then example 5, triangular frameworks are rigid. So it says to prevent a doorway from collapsing after an earthquake, you can reinforce it. Explain why the doorway with the diagonal brace is more stable while the other one without the brace can collapse. Okay, so if we look at this, it says in the doorway with the diagonal brace, the wood forms triangles whose sides have fixed lengths. The side-side-side congruence postulate guarantees that these triangles are rigid because a triangle with a given side length has only one possible size and shape. The doorway without the brace is unstable because there are many possible shapes for a four-sided figure with the given side lengths. Now, the only thing is I could see that being with a window, but if it's a doorway, I'm not real sure. You're going to have to duck or crawl over to get through it. So I can definitely see how it would be more stable. But it might be a little more hard to get through. All right, example 6, congruent triangles in a coordinate plane. All right, here we go, and I can see I've got a formula here. Which formula should you recognize this as without even looking at the name of it? Just
Distance
look at the formula. It's the distance formula. I can see that my first clue is I've got that square root symbol. My second clue is I am subtracting my x values and squaring them, and then adding it to my y values that have found the difference of the y values squared. Okay, so it says use the side-side-side congruence postulate to show that triangle ABC is congruent to triangle FGH. Okay, so in this, we can see that we've got to use our distance formula to say, hey, is the distance from here to here equal to the distance from here to here? Is my distance from A to B the same distance as it is from F to G? is the distance from C to B the same as H to G? Okay, so I can do that using my distance formula. I use my ordered pairs that they've given me. A is -7,5, B is -7,0, C is -4,5. F is 6,2, G is 1,2, H is 6,5. So the first one says because AC equals 3. Okay, so let me, hold on a second. All right, so what I want to do first, I'm trying to say that they didn't tell us. Okay, so let's look at this for just a minute. Okay, notice that when I have a triangle on the graph, I can easily count the measure of this side, okay? Because I can use these blocks and count it as a unit measure. So I can see I've got 1, 2, 3. So this side is equal to 3. Going down, I've got 1, 2, 3, 4, 5. They did not tell me this in the problem. They did not tell me that that side was 3 and the other side was 5. I had to figure that out. I can figure out the length of my measures as long as they're running exactly along one of my grid marks. But notice here, this is not running along the grid mark perfectly. I don't have perfect intersections. So I don't know what that distance is. I can't just count it like I just did with my two sides, okay? Therefore, I've got to use my distance formula to be able to tell the distance of CB, all right? I'm able to figure out AC and I'm able to figure out AB, but I have to use the distance formula to figure out BC. So that's what they've done here is they said, okay, I can see that my ordered pair for B is -7,0. My ordered pair for C is -4,5. So now I'm going to plug them in. Remember, if you need to label your little points as you're working and say, this is X1, this is Y1, this is X2, this is Y2. Now remember, there's no magic in figuring out which one's point 1 and point 2. I'm going to get the same answer whether I let B be point 1 or point 2. Okay, it does not matter which one I decide is point 1 or point 2. The main thing that matters is that I'm consistent. Whichever point I'm using as XY, X1, Y1, I have to have the other one as X2, Y2. I can't combine them and crisscross them, okay? So here they said, okay, I've got -4 is X2. I've got -7 as X1. Now, one thing to notice here is notice how they use parentheses for X. So basically, when you're writing this, you could go ahead and do parentheses to put in X1 and X2, and then that way you've got your symbols correct. You can pay attention because this was a -7 here. When I'm working with these, I've got to make sure that my symbols work out right so I can have the right number before I square it, because squaring a negative is going to become a positive. Okay, so again, they put in X1, Y1, I'm sorry, X1, X2, Y2, good grief, X2, X1, and now I have Y2 minus Y1. I would still get in the habit of going ahead and putting these in parentheses, even though they're positives, just because then I'm used to writing parentheses every time I'm plugging in an X value or a Y value, but that's going to be totally up to you. So, okay, they said -4 minus a -7. Remember, minus a negative is the same as plus a positive. So -4 plus 7 is a +3. And so now I'm going to have 3 squared. Over here, I have 5 minus 0 is 5. So now I've got 5 squared. 3 squared is 9 plus 5 squared is 25. The square root of 9 plus 25 is the square root of 34. Okay? Again, if I could simplify that, I would. But think about the prime factors of 34. 34 divided by 2 is going to be 17. So 2 and 17 are both prime. There's nothing I can do to simplify that radical. If I could simplify it, I would by listing prime factors, choosing my buddies, pulling them out, all that good stuff. So we found that one side is the square root of 34. Now we've got to go to the other triangle. Again, when I look at it, I'm able to look and see that the side of this one is 1, 2, 3. This one is 1, 2, 3, 4, 5. Okay, so now I've got to find the distance of GH. G is 1, 2. H is 6, 5. Okay, so they said that G, that was my X1, whoop. Actually they used G as X2, or as my second point. So they said this is, nope, they didn't. X1, Y1, X2, Y2. So they plugged in 6 for X2, 1 for X1, 5 for Y2, 2 for Y1. 6 minus 1 is 5, so I've got 5 squared. 5 minus 2 is 3, so I have 3 squared. Again, I could put this under here when I'm doing step by step. That'll be 25 plus 9, which also equals 34. So when I look at this, I've got my answer of 34 here, my answer of 34 here. So I know that every side is the same. So by using the side congruence postulate, I'm able to show that those are congruent triangles. Okay? So it takes a little bit of work. Also, they are expecting you to start figuring some things out here. Just like they did not say AC is 3 and AB is 5. They did not tell us that. They are expecting you to know how to figure those measurements because it's on a graph. All you have to do is count it. What you can't count is a diagonal. Therefore, you have to use the distance formula. Which leads us to some practice. Okay. Real quick, since we've got about 4 more minutes left in class, before we do the guided practice, let's go ahead and look at our homework. So this will be page 216 through 218. We will do numbers 7 through 35 odds. 7 through 35 odds. Now, $25 and $27. Let's look at those for a minute. What I would like you to do on 25 and 27, since it says you're supposed to write a proof, let me go back and find them. Okay, so it says to write a 2-column proof or a paragraph proof. What I want you to do is in paragraph form, I just want you to write everything you know about those. Okay, I want you to dissect these diagrams, okay, and then just write everything you know about each diagram. Okay.
So we're not doing a proof?
You don't have to write, basically we're going to kind of use it as what, it's not going to be an exact paragraph proof, but just write, you can just write everything about the figures that you know. Okay? You know that they have given that you can see in number 25, you can see the sides that they have given that are congruent. You can see that CM is a common side for both of them, and we know that CM is equal to CM by the reflexive property, okay? So thinking through each of these things, use what you know, all right? We know that M is the midpoint of AB. Therefore, if M is the midpoint of AB, then AM is equal to MB. That means those are equal sides. So if I've seen that AC and CB are equal, I know that CM is equal there, and I know that M is the midpoint, so AM and MB are equal. Therefore, I've got side, side, side. And I was able to do all that. So basically, that's what a proof is telling all the things that I know are true about my figures. So you're going to kind of do it in a paragraph format, okay? And the best way that I want you to start by doing that is telling me everything you know about those shapes, okay? Don't stress about the diagram, the statement, and the reason and all that stuff. I just want you to tell me everything that you know by looking at those figures, because I'm wanting you to make those connections more than I'm wanting you to worry about what is number 1, what is number 2, what is number 3, okay? So that's for 25 and 27. Just tell me everything that you know and how you could prove whether they're congruent or not, okay? So actually we will go ahead and you can glance over the guided practice if you want to, but then we'll go ahead since we are out of time. That is going to be your homework. Okay. So we have got, Tyler, don't you turn me off. I'm watching you. No, just kidding. Okay. So we've got the pages that we have for today. We have what we had yesterday. I've sent you the test. We have got a break next week. I hope y'all enjoy it. I am a little behind on grading. I did not grade anything last night because I fell asleep because I'm exhausted like I know you guys are. So if you'll give me a little bit of grace, my plan is to have all the grades finalized by Sunday, okay? So Sunday, I'll have your grades finalized and we'll keep on rolling, all right? I hope y'all have a great fall break. If you need help with anything, let me know. And I will see you guys in 2 weeks at the co-op.
Bye, Miss Jennifer.
Bye, guys. Bye.
Thank you.
Thank you, guys. Let me know if you need any help, Keely.
Yes, ma'am. Thank you.
And I didn't send you that list yet. I will send you that this afternoon.
Oh, that's no problem. Thank you for
Okay.
sending it.
You're welcome. Thanks for being patient with me. Bye. See you soon.
Bye.